Alright, so let's go through this question, which is the Independent Paper 2020, question 22, 9 marks. What you need to do firstly is highlight the key points. So we know that the first and last image is 2.2 meters, which is a displacement of 2.2 meters. If you look at the frame, every frame is about 0.1 seconds, so from there to there. If you count across, you have 7 frames in total, which means the trip time is 0.7 seconds. We are trying to find, using projectile motion equations, the maximum height. So to find the maximum height, Sy is max. We know at that point Vy is 0. In this question here, we need to identify 2 assumptions we make in our calculations to find the maximum height. Now, some of you might suggest Vy is equal to 0. That would not be accepted in the actual exam because those are kind of the assumptions that we already talked about in class. They're actually asking you to infer it from this diagram. So assumption number 1, you can say the trip time is equal to 0.7 seconds because we found that from the time frames. The next one we can find is the person themselves. So this person is not a point mass, so they do have variations in their height, but we're not accounting for that. So assumption 2 does not account for height of human. We will count it as a point mass object. Okay, so let's look at what we create here. So I'm trying to find the maximum height, so I'm looking for Sy. I can plug it into this formula to get this particular equation. So that's one of them. I know what t is, I know what the acceleration is, because that's just minus 9.8 meters per second squared. But I do not know what uy is. And to find uy, I am going to use a different equation. Put it in a different color. I'm going to use this equation. The reason why I'm using this equation is because I do know what ay is. I also know what the time is. I know also that v is equal to 0. So v is 0 uy plus, let's make that bigger, ayt. So minus 9.8. And the time is 0.35, because that's half the time it takes to reach this point here. The final answer should equal to 3.43 meters per second upwards. So that's how you do that. Now that we know what the initial velocity is, you can work out the maximum height. So if we plug it back into the formula, 3.43, well, don't forget to square it, 0.35 plus half, 9.8, 0.35 squared, and you should get an answer of roughly 0.60 meters. And that's the maximum displacement. So let's go to question B, which is the velocity at which the student is launched upwards. Now, this comment of upwards might imply you're trying to find uy, but remember, we already found uy down here. So what the question is actually asking for you to do is find the resultant velocity at which it was launched at some random angle. How fast was this person jumping at that particular angle? Okay, so you need to find uy and ux, solve it as Pythagoras Theorem, and you should be able to find it there. So I already know what uy is, so I can just write that down. That's 3.43 meters per second. I'm going to change to a different color to find ux. So ux can be found because we already know the displacement and time t. So t in this case we're using 0.7 because we're looking at the entire trip time here. So ux is going to equal to displacement over time, which is 2.2 over 0.7. Okay, so if I just plug that into my calculator, I get 3.14 meters per second going in that particular direction there. So what you need to do now is solve this through Pythagoras Theorem. So u is going to be square root of ux squared plus uy squared. So 3.142 squared plus 3.43 squared. The final answer we get from that is 4.65 meters per second. Last thing we need to do is find the angle. Remember, this is a two-dimensional motion, so we need to do that. If we look here, that is our adjacent side, and that is the opposite side. So we can use tan theta. So theta equals inverse tan uy over ux. If I rewrite that out with the numbers inside, it is 3.43 over 3.14. So theta there will be approximately 47.5 degrees. So let's just write an ending comment. Therefore, human travels 4.65 meters per second at an elevation at 47.5 degrees above the horizontal. And that'll be the answer to that. So if you're not quite sure how we got to all this, please replay the video. If you do get it, good job, and make sure you try the next question.